Well, good evening, ladies and gentlemen. This is Mr. Picard, your well-rounded math teacher. A shout out to all the people that like chocolate pudding. Um, we're going to do the second day of complex numbers. Spending a couple days on this, and today we're going to get into working with the imaginary unit, which is I. And I think that's right here. Okay, it is. We did this yesterday. We're going to talk about Rene Descartes, the French mathematician that discovered what was called the imaginary unit. For example, if I had something like x squared equals 1, that'd be easy. You take the square root of both sides. Square root of 1 is 1. But if I had a negative 1 over there, and to solve for this, we have to take the square root of both sides. X equals, well, what's the square root of negative 1? Well, you can't take the square root of a real number. It's not a real number per se, but it can be an imaginary number, I. So what I'm saying is I equals the square root of negative 1. So from now on, whenever you work with a negative number underneath the square root, it's not a real number, but it is an imaginary number. So I is what we call is the imaginary unit. It's used a lot in electronics when you get into electrical engineering, things like that. They use the imaginary unit. And it's used for a couple other things also. So there's uses for it. Now they talk about I squared being equal to negative 1, because we're going to work a lot with I squared. And where does that come from? Well, I guess it comes from here. I squared equals I times I. Well, what is I? I is equal to the square root of negative 1. So that's the square root of negative 1 times the square root of negative 1. There's your two i's right here and here. Well, we can put those together and say that's the square root of negative 1 times negative 1. I have two factors of negative 1 there, so I can pull that out of the square root symbol, and I get negative 1. Therefore, I squared equals negative 1. So you're never going to put I squared in a problem. You would simplify it and call it negative 1. So you can go from an imaginary unit, I, just by squaring it, it becomes a real number again, negative 1. Example. There it is. So we're going to go to this problem right here. It's right next to it. And to solve this, 2x squared plus 2 equals 0. We're going to subtract 2 from both sides and get 2x squared equals negative 2. Dividing both sides by the 2, I get x squared equals negative 1. Now, how do we solve this? We're going to take the square root. That's the opposite of squaring something, so these cancel each other out. Square root of this side, and I get x equals. Now, when you take the square root of a square, you have two answers, plus or minus, and this is now going to become I. Square root of negative 1 is I. So x equals I, or negative I in this case. Those are my two answers with the plus or the minus. And going in here, work with this a little bit better. We're going to simplify the square root of negative 18. Now, if it was just 18, I'd find the prime factorization and go from there. But the way we're going to do this problem is take that negative out. Say that's the square root of negative 1 times the square root of 18. Well, the square root of negative 1 is equal to I. So this is basically I square roots of 18. And then go ahead and simplify your 18. Pull out what you can. This is 9 times 2. And that's 3 times 3, though I have 3 prime numbers. So this is equal to I square roots of 2 times 3 times 3. I have two factors of 3, so I can pull it out. When I pull it out, I multiply it by the I on the outside. So it's 3 times I square roots of 2, or you'd simply write 3I square roots of 2. That is our simplified answer from here. As soon as you see this negative underneath the square root, you know you have an imaginary number. Okay. Let's go down here a little. Ooh. There it is. Oh boy. Anyway, right there. So I'm going to pull that out and put I on the outside of my square root, 125 x to the fifth. This is no different than the square root of -1. Square root of -1 is equal to I. 125, breaking it down as 5 times 25. 5 is prime. And then 5 times 5. These are also prime. So the way I'd write this problem is I square roots of 5 times 5 times 5, x to the fifth. Well, that's an x squared times an x squared times an x. 2 plus 2 plus this 1 right here equals 5, so that's x to the fifth. And the reason I wrote it as x squared is for every two x's, you can pull it out and put an x on the outside of your square root symbol. So there's two 5s. So this is going to be I times 5. Pulling those two 5s out. Times an x. Times another x for those two that I'm pulling out. I can't pull out this 5 or this x. So they stay inside the square root. That's 5x. Now cleaning all this up, you usually put your number first, then the I, and then your variable. So this is 5I x squared square roots of 5x, and it is simplified. It's not only an imaginary number here, it's an imaginary expression because you're working with the x's here now. So, let's see what else we got here. Multiplying. Okay, first thing I want to tell you here is you cannot just multiply two numbers or two radical terms when there's negatives underneath there. You have to pull those out first. If I was to multiply these two, and you can multiply radicals, if I was to multiply these two and say this is the square root of -10 times -15, I get the square root of 150. No, now it's no longer an imaginary number. Well, that's not the case. You can't just get rid of the I by multiplying two negatives together. This is how you take care of it. This becomes I, pull that negative out. It's just the square root of -1, which is I. I squared is 10 times I squared is 15. Now you can multiply them because we're not going to lose the imaginary unit. I times I here, multiplying the ones on the outside, is I squared. Square roots of, well, that's 10 times 15. Putting it back together. Anyway, we know I squared is equal to -1, so this becomes a -1 on the outside. Square roots of 10 times 15. Okay, I'm going to break these down. 10 is actually 2 times 5, and 15 is 3 times 5. So I'm going to say it's 2 times 3 times 5 times 5. And what that means is I have two factors of 5. I can pull that out and put a 5 on the outside. When I pull that 5, I'm going to multiply it by the -1. So that's -5 square roots of 6. -5 square roots of 6. Very good. Anyway, what else do we have here? We've got another one cooking up here. And, well, I think what I'll do is I'll let you guys try this one. And I don't even know if it's on your sheet there, but just put it in there somewhere on your note sheet. And we'll look at this tomorrow. I do, however, make sure you copy that down. 3 squared roots of -24 times the square root of -125. I want to show you this one. Multiplying two imaginary numbers. There is no square roots. But I know this I is the square root of -1, and this I is the square root of -1. How we multiply these two is simply this. You multiply the -2 times the 7, that's -14. And just like variables, you multiply the I times the I. I times I is I squared. So I end up getting -14 times, well, I know this, I squared is equal to -1. So I end up getting positive 14. Positive 14. These ones we'll get into tomorrow. I want you guys to try this. Try multiplying, we'll say 6I times I times -5I. You guys come up with an answer for that tomorrow, and we'll talk about that and talk about the rest of this worksheet and finish up complex numbers or imaginary numbers. Peace out.